And now we're very pleased to introduce to you Ken Gall. He's going to tell you about Restored. We want you, now that you've got a little caffeinated energy, make sure you give him all your thoughts, and energy is the follow-up. Ken, thank you very much. Chris and Sotomayor says wonderful things about you, so we're really happy to have you here on Media Cups. Ken Gall, let's give him a good welcome.
All right, thank you all for having me. I really appreciate the opportunity to present here and tell you a little about what we're doing. So I want you to imagine for a second that you're in a car accident, and it's just a bad thing to imagine, I'm sorry, but imagine you're in a car accident and you shatter the bottom half of your tibia. If you do this, you don't have many options. And so this is a real case. There's a young woman, about 19 years old, shattered the bottom half of her tibia, went to a hospital, and the doctor put her in an X-fix. This happened recently. This is not like 20 years ago. When you get put in this X-fix like this, it turned out the bones were shattered so bad they didn't heal, and so they told her she had to have an amputation. So rather than do this, we brought her to Duke and used our company Restor3d to build her a new bottom half of her tibia out of titanium. And we can build it out of a scaffold material. I'll pass this around. It can hold about 10,000 pounds and also is 85% porous. It's printed out of titanium, and that allows the bone to grow through this and rebuild her. She can then rebuild her own leg. Another case, I'll give you just an example and then kind of show what we're doing. We had a 17-year-old patient, osteosarcoma, so a very large osteosarcoma in his pelvis. And so you're faced as a young patient like that with two choices. One is to have a very large part of that removed. In this case, you have to remove the entire side of the pelvis. But if you remove the entire side of that pelvis, the problem is that then you can't walk, essentially. So you remove it, there's no way to reconstruct that in a way that you can walk, because you can't attach your femur back to there. So with that patient, that's also a 17-year-old, we rebuilt their pelvis completely out of titanium. And this allows the surgeon to, and this is a pelvis that's custom printed exactly to match the other side of the patient's pelvis. So why hasn't this been done before? What's happened? There's been advances in 3D printing technology, but also if you look at the way medical implants are done, it's a very generic, slow, and static life cycle. You basically have a need, surgeons come in and look at it, that's a flat foot. They design something to help fix that flat foot. They then build a whole bunch of inventory, send this inventory out to the field, and then hope that it's going to sell. In some cases it sells, they push it through a distribution channel. This distribution channel then brings it to surgeons. The problem is there's two problems with this. One, it doesn't necessarily match the patient's needs. So the inventory that's sitting out in the field won't match those two patients that I had needed. In some cases it matches the patient needs, but the surgeons don't like it. So you're kind of stuck in a dilemma where you either don't match what the surgeon wants or you don't match what the patient needs. And in medical implants, those are both your customers. And there's others like the hospital and others that have stakes in it. But you're really making things for patients, but you're also making things for surgeons. And so we really want to change that. And this is the way that every single medical device company does it right now. So in the future, we believe that we can have patient-specific implants, so implants that match their anatomy and their biology. And so that's a 3D printed cobalt chrome talus. I'll pass that around. You'll notice this is a lot heavier. So the first thing I pass around is titanium. That's cobalt chrome that allows you to have a polished surface to interact with a joint. And so we can build them to actually match both the patient's anatomy and the biology of what they have healing. So for example, we can make something very, very highly porous if it's a young patient that's going to grow in bone well. We can make it much less porous if it's someone older that needs a stronger material. We also want to design things for surgeons specifically, so how we design for their evolving needs. And so we asked 6 surgeons how they would use it for an Evans wedge, which is a very standard procedure, and we got 6 different answers. And this is part of the problem with a static inventory cycle, is all surgeons have different techniques, and that their technique that they're comfortable with is the one you want them using on you as a patient. And so we are working with surgeons to design an implant specific for them. So how do we do that stuff? I'll just give you some examples of 3D printing. We print all kinds of different materials. The first one is polycarbonate urethane on the left. That's a high-strength elastomer. We print airway stents with that, so I'll pass that around. This is an example of that. The one in the middle is titanium. And that's actually a powder bed process where you use a laser to fuse titanium into a three-dimensional structure. And then one on the right is we print instruments and things from a plastic material, and that's a resin bed. So that comes from a resin. We transform a resin into something like this, which is an instrument that's used temporarily to insert a spinal cage. So what are the markets we're going after? It turns out we're flipping the entire medical device market in the way that things are done. In normal startups in medicine, you're stuck in one track. You build one area, you then take that area and you build inventory, you hope you sell it. If it does well, you maybe have a second product and then someone acquires you. We're actually not worried about market size. We're not worried about which type of market it is. If we can print something that will help patients and surgeons are interested, we'll go into that market. And part of the reason we can do that is we build on demand. So we don't build a million pieces of inventory, we build it as it's ordered by the surgeons or needed by the patients. So I'll just give you a quick blast of the markets: foot and ankle, spinal fusion, foot and ankle arthroplasties, airway stenting we've done, osteosarcoma reconstructions. We've already worked in these 5 areas. Sports medicine we're building, that's like tissue reattachment. Craniofacial, breast lumpectomy targeting is an area we're looking at. Trauma. So right now we can turn around our products in about 2 weeks, and we're getting that down to about 1 week. And if with a 1 week lead time, we can do trauma. And then vessel stenting, so we're looking at cardiovascular applications as well. And these get farther out, areas we haven't worked in. Just quickly, what's our business strategy, our kind of overall plan? First couple years, we've been in operation for about 2 years. We raised money to build our operational structure. So we have that, it's down in downtown Durham. We're in where the old Elf bikes company was on Corporation. We built a whole bunch of research, and then we entered our launch markets through key surgeons using what's called the FDA custom exemption. So that's an exemption where we are allowed to do specific cases that are ordered for surgeons. We also submitted a bunch of clearances to kind of get into non-custom markets. We're in the beginning of year 2.5. And this is kind of our second phase of fundraising we're going through now. We're going to build a library of 510K clearances so we can operate in many areas of medicine at once. We're doing animal clinical materials research, and then we're testing various sales models because we have a very different structure, and it's hard to use a standard distribution channel, and it's also hard to hire direct reps. Direct reps in medicine make a lot of money, so you end up needing $4 or $5 million to do that. Years 5+, we eventually will take a very large round if we're successful in this middle side, which I'm hoping we will be successful. And then we will use that to expand our infrastructure and start looking at harder questions like, can we do point of care solutions? So can we put printers and things in closer to where the patients need them? Can we put them in remote locations where people need them? And depends on the printing method. Just a little about the team, and they said mention something about myself. This is the team. It's a relatively young team. I'm the oldest by a pretty large margin, so we tend to look for young talent that's very hungry and very wants to take risk and try something new, wants to build something unique. We have a kind of team across a lot of areas, and we have some people that aren't listed on here. My background is I'm a professor at Duke. My job is to help entrepreneurs at Duke. I'm the Associate Dean of Entrepreneurship, and then I also have a research lab that works in 3D printing. And then I have started about 5 companies myself. This is the 4th company that I've been a part of, and they're either all in operation or are have been acquired. It doesn't mean I haven't had a lot of failures within each of those companies. So just highlights, and this is my last slide. What have we kind of done the last couple of years? And I'll tell you what we're looking for and the things we need. We built a facility with 2-week turnaround. Everyone else that are doing similar things. There's a couple other competitors doing something like this. They can turn around in about 2 or 3 months. We've done 3 FDA clearances. Those will clear soon, by the end of the year. We've done about 60 custom cases, like what I just showed you. We closed the deal. In some areas, we license things. So if there's a lot of complex instrumentation required for something, we have to partner with someone to do that. And so we closed the deal to do that. And we continue to publish and do research on our areas to show that this is an area of medicine that will evolve. We're doing a $2.5 million raise that will start beginning of next year, about a $15 million pre-money valuation. I don't know how much stuff you all put up here, I just put it directly up. Capital is going to be deployed on parallel clearances, science, R&D, and then what I'm calling stealth sales and marketing efforts. So we're not launching formally, we're waiting until we have all of our clearances. In medicine, there's some medical implants, there's some issues. If you kind of formally launch and say, aha, we've arrived, and you don't have all the clearances in place, it can sometimes work against you and you can't advertise in certain things. And customs are kind of all word of mouth. You can't really advertise those. What are our challenges? We struggle to find engineering talent. There's people that are willing to come in and work in a higher risk, newer environments, and even young engineers, sometimes that's challenging to find. Technicians, so we have people that need to run printers and do things that are willing to try something new. And so we hire machinists or different people. So we do look, I think maybe your service might be helpful for us. And we're completely open to veterans and probably more than open. And then people willing to learn new processes in general and risk takers. What we're trying to do has a lot of risk, not only with patients, but with jobs and things. And we think we'll survive and become a great company, but we're really truly trying to do something different, and there's always a lot of risk to that. Thank you.
Fantastic. Thank you. I would like to ask your indulgence. Let's go to about 5 after. I know we generally try to stop at 10 o'clock. You always hang out and network a little bit more afterwards and build connections there. But we did have a couple little technical glitches here. So let's give Ken the courtesy of going a little bit beyond, if you will. Questions, please, input. Rick.
Two things. Have you taken a look, you're looking at your private capital. Have you looked at US aid and do this work over in Africa, where some of the rules and regulations are stringent to try some of these techniques?
I did have one of my students that went over there with some of our printing stuff, but we've not done a lot yet. And so we are handling the regulations and different things kind of head on here and working closely with the FDA to build this out. I happen to have a former student who's also at the FDA that runs the printing division, so it helps a little. But we're open to unique plans or partners that would help us go abroad in ways that would make sense. And it depends on the type of implant. The printers that do some of the titanium are expensive and take a lot of power and certain consistency, but some of the ones that don't do that can be on wheels and are very easy to move around and do.
And the other question I had was, I know you use a lot of metal based. Have you looked at using industrial hemp?
Can you say that again? I use what?
Industrial hemp. Industrial. We had a person speak that was from the eastern part of the state that dealt with amputees and actually made extremities out of industrial hemp.
Okay,
so I'm just thinking that you could use that internally for some of the stuff you're doing.
Interesting. So and you're talking about a prosthetic?
Yeah. Well, prosthetic or some of the things you're doing here.
Yeah, I have not looked at it. No. It would depend on the mechanical properties. Right. So most of our stuff is in a very high load bearing application. And ours is all implanted, meaning so it has to be survived inside the body. Right. That I don't know about that, but I'll look.
Thank you.
Two quick questions. Are any of your products generalized, or is each one specific for a specific patient?
Yeah, it's a great question. So we do patient-specific products, but we also do what would be normally considered a generalized product. And so there are some where surgeons, you don't have to customize to the patient, but even in the generalized product, we design it for the surgeon. So we might design a set of 20 implants that they use in a normal case, so that would be considered generalized. But what we do differently than big companies is they just put out 20, 30, 40 sets of that to the general surgeon population. We work with the surgeon directly to make a generalized set.
And the second question is this just for Duke? I mean, is this for Duke surgeons, or would you send it all over the country? This could be a nice way for Duke to make a lot of extra money as well.
Yeah, so Duke is a partial owner of the business, so we spun it out of Duke, but they're a silent owner in the sense they own a little bit of equity when the company's spun out. And we do cases at Duke, but I'm less involved in those because I work at Duke also. There's some conflict. But we do cases all over the country.
That piece that you just said about the generalized thing, I was confused in your deck.
Yep.
Because you talked about the state of the problem being that things are slow, generic, and then you talked about an up round of like, hey, we want to do some generalized things, and so that was confusing. But that point that you just made there it seems to me to be the thing that removes the confusion, because you're doing a general thing, but it's for a specific surgeon, so it's not. So that might be a point that would be useful to help clarify a little bit earlier.
Yes, thank you.
Yes, Dominic.
I think he's running the question.
What is the difference between the cost of production for what you're doing in printing versus traditional cost of medical implants, and how does that impact the cost for the patient?
Yeah, so complex question. I'll give it a quick answer if I can. So the raw material costs are about $1 a cubic centimeter. So you can just think of that roughly, and that's actually pretty cheap. So the raw materials. And so you'd have trouble if you went into an application where you needed something to cost 2 cents. But medical implants sell for a decent margin. So we have plenty of room there in terms of cost. An example would be a spinal fusion cage, which is on the end of I sent you. That might cost us $30, $40 to make, and then the ASP will be about $1,000 typically. So there's a big margin there. Now the problem is we have to carry medical device insurance, we have to pay commissions, so it's not as good as it looks, but there's plenty to work. How it saves money for the patient is a more complex issue because the device costs are actually a pretty small fraction of the overall costs, even at that. But we are working with surgery centers that are willing to do that. It's more complex with hospitals, where a surgery center might, the surgeons are motivated to make the cost lower for the patients, and so then we offer our implants at a lower cost and the patients see those costs. Our challenge is if we just offer at a lower price and the hospital just makes more money, it doesn't help the patients at all. So, and also there's weird things with insurance where the insurance reimbursement is set at some certain value, and so again, they will try to push our implant costs down, but again, it's just for them to make more money, they won't change it for the patients. And so that's a way more complex issue we're not really addressing well, but I don't know if we can or not. But having said that, this would provide the opportunity for that eventually. So we're not inherently expensive, and med device is just an expensive area.
Great. Question in the back, and then we'll come up to you too, John.
It's kind of like piggybacking on this a little bit. When you ratchet up all your total costs to include your overhead, what does that come up to per cubic centimeter? Because that seems like a nice metric to work with. And then secondly, on the operational side, are you saving the surgeon a lot of time and effort, therefore decreasing the overall cost of providing the surgery in the procedure, and plus recovery period?
Yep.
If one of these is put in and it's so accurate, how does it, the body accepts it quicker, or does the recovery period get cut down? Because I guess that's all got to get factored in, right?
Yeah, so if you did a full cost analysis, there's a ton of different factors. So for example, actually amputation, there's a lot of costs around amputation, even though it seems like in theory, a simple solution. There's a lot of costs around that then we can get around and save. We do save the surgeon time. We design them implants that they want to use exactly in their procedure. That generally is faster in the OR and does save OR time. And so there are things like that, but it is, I think, overall a complex issue. One thing I'll mention is the overall cost. That's the raw material cost. That's the baseline. You're correct. It depends on the implants, but you might end up, and I know more on the implant costs. Implant costs won't ever be more than 25% of the sales price usually, but they will usually get down to about 5%, including everything.
Okay, great. We have two.
Fully loaded. Yeah.
Thank you. Two
Well,
questions
fully loaded,
here.
that's cost of goods. So the parts to get it on the shelf cost. Now you've got marketing, sale.
Yeah, I was going
Yeah.
for that. That's
Yeah,
what I was
yeah, the cost.
Chris, not
So,
bad.
yes, hi.
You too, Jen.
Yeah, I
Jessica.
noticed the slide up there, a few seconds. I'm not sure, did you have any medical doctor or licensed physician? Were they employees or advisors?
This is just direct employees.
Direct
so
employees.
yeah,
Okay.
and just to be very clear, we don't implant anything ourselves.
Yeah.
So it's only done by
Right.
physicians. And so we have a board of physicians that helps us and then also works with other surgeons to help learn our implant.
Okay.
Yep. Yeah. So we're
You
always
might want to
open.
have a footnote or somewhere in there about clinician, practicing physician.
Yeah, okay. Yeah, it's just somewhat of a time issue. So I have a slide normally that's all the different surgeons we've worked with. Of course, we've worked with probably hundreds of different physicians, but we're always open to new ones.
Right.
So, my question's related to what you brought up in terms of outcomes, which is what the medical community cares about. I mean, it sounds like you got a middleman in between where you've got a component in this overall outcome, which surgeons are involved and all these other people. So that component can get marked up by the hospitals or played games with, so that sounds like a real challenge in terms of how you address. But if your part that goes into the entire equation has a better outcome over time, how long is it going to take you to establish those outcomes so that the community that's choosing the product says that outcome is valuable?
Yeah.
Right? It's an improved outcome over these other stock parts. It's
Correct.
custom parts.
Varies greatly on the procedure. So the first two I showed you, they don't really have any other options, right? So the outcome there was staving off amputation or inability to walk. So there we have a pretty direct, quick story. Where it takes longer is if we drive some patient-specific implants surgeon-specific implants in spinal fusion, let's say. You know, you need to build that case. It will probably take 6 months to a year to 2 years to build some of the patient data. In some cases where you have a procedure that's happening once a month and it's just really spread out, you need to get 30 patients, it could take 5 years to build outcome data. But many med device companies don't track or watch outcome data. It's become a big hot button item in terms of insurance reimbursement and different things, and so we're kind of looking at that from the start. So we work with our surgeons to kind of track data in ways that other companies do not.
Other questions? Yes, Mark.
For the bone-related products, how long does that take for the patient to recover? I mean, cells, et cetera, have to grow into it,
Yep.
most of the cases, et cetera.
Yeah, it depends on the type of reconstruction, but you're looking at so the patient with both the hip and the both those patients started walking in a couple days, but then it takes a much longer time for it to fully integrate. So you're talking 5 months or so to fully integrate, and then they are in a tough situation. So if they don't fully integrate, eventually those implants can break as well. So that's one of the challenges in trying to design something that will eventually integrate. All the patients like that are well aware that they don't like their alternative, so they're trying something that's riskier in some way.
Can they get through the metal detector at the airport?
Definitely not.
With their X-rays.
Yeah.
Right.
Yeah.
Thank you. So one final question, Ken. What as a community can we do that would be of most value to you? What do you need most that we could help with?
Yeah, I mean, I think probably in terms of recruitment of people, and like I said, we were always trying to look at hiring people at different levels and moving. That's probably one of our biggest challenges. It's a high-risk environment. It has to be people that are willing to do. We found that just recruiting straight out of school, like straight out of undergrad, has been not as good for us. I have good connections with the universities, but we do better with people that have worked in a job and they think, oh, this is kind of stagnant. I want something exciting and new and risky and something that's really going to make a difference. And that's one of the things we struggle with, is finding those people. And networks are always better for that for us.
Are you mostly focused on sales, marketing?
Not right now. We're mostly focused on technical side, technicians, engineering, these types of things. So we have one salesperson, and she kind of moves around and helps a little bit. That's it. And even her, we found her through a network connection. She wasn't in sales. We generally do hire people that are willing to learn new things that are outside of their area.
Thank you.
Generally, what kind of engineers specifically?
Mechanical and biomedical are the main two that we hire.
Excellent. Thank you very much, Ken.
I'll just mention one other thing. Thank you all for having me. And part of our plan is to send some more biomedical companies here. So I work with a lot of different ones. We started with my company, not for any particular reason other than I could come present and see what it was like. And then we'll send a bunch of other companies through that are all kinds of different things and different than this.
Awesome. So hang tight for one moment, if you would. Dominic's gonna, and if Robin, come up and stand here with Ken.
You can't resell those parts. You still have
Yeah, we'll get the parts back. Can we get both of you up front here?
Oh, yeah.
For a community picture while you get mugged?
As is our tradition at 1 Million Cups, so all of our new presenters, we make sure we mug you.
Nice.
So, all right. Thanks for being here.
Okay, thank you. So we're a couple minutes over, but here's what we'd like to do. Let's take 2 more minutes. If you have some community announcement that pertains to this group, an upcoming event, something that you feel like would be of help or of interest to this group, you can write it up on the board here. There's some markers and everything in the back.